Okay, this is part 2 of our computer explosion vehicle, and we got some really good history with this that we did not know going into this, or at least for part 1 of the video. And what we found out talking to our evening instructor is that when this battery exploded, he was right there with the guy, so they did not reverse polarity jump start this thing. And it was when they switched the charger to a 200 amp mode that this thing exploded. And I talked to some of the students and they said the car ran, it started and stalled when they would step on the brake pedal. That was the original complaint. It either stalled when they stepped on the brake pedal or when they were coming to a stop. One of the two. The student said brake pedal, but you know, there can be a communication issue there. But that was the original complaint. They started working on it, battery went dead, put a charger on it, hit the boost, battery exploded. The car did not start after that. What they found when the car did not restart is they were missing spark, they were missing everything. And they found a whole bunch of blown fuses. So not sure exactly which ones were blown, but we were not aware of that. We didn't find any blown fuses. Our powers and grounds were all good. We had spark, and so just a little bit more into this, it was helpful to know that there was a bunch of blown fuses too. So those all blew at the same time. The computer board blew out. I did have a mention from one of you guys that said maybe the alternator is what caused this, and that is not the case. We do know exactly what happened, and I'm going to show you that right now. There's more to the story too, I'll share with you in a little bit here, but I want to show you the cause of this battery explosion, and it was the battery charger. If you notice, I'm connected to it. Black lead, black on my voltmeter, red lead for the charger, red on my voltmeter. I'm going to turn it on, watch the meter itself. Notice the negative polarity that we're showing on this voltmeter. If you look closely, turn this off. If you look closely at this, you can see that the wire was broken here, and on this one the wire was broken here, and this was repaired. And what someone has done is they've reversed the leads of the charger, and this is what caused this problem. One of the things that we can say with absolute certainty right now is this vehicle has another problem. This was definitely caused, and we're going to have further tests that we're going to be doing in part 2 of this video. So you see what the real cause of this was carelessness in installing some leads back onto a battery charger. And again, fortunately no one got injured. Everybody's okay. There was a good question that I had from one of my students, and that was, well, before we put the new computer in, don't we want to check things and make sure it doesn't happen again to the new computer? And the answer is always yes with that. Anytime you have a computer that is damaged or has malfunctioned, you want to check outputs and things like that. In our case, it was a catastrophic failure. It wasn't a particular output that would cause that condition. But we were concerned, you know, we're about to install a new computer. For sure we'd be concerned that this could happen again, but now that we know exactly why, we're not so concerned about it. So our computer's sitting right here, and for those of you that have never dealt with one of these, the procedure is to remove the PROM chip, and this is before we did electronically erasable EEPROMs is what they're called. You had to swap them out. So this is really the program for the car is in here. We had to take this out of the old one. Now one thing we don't know is, did this thing take a hit too? You know, are we going to have some kind of corrupted data? It's possible. We don't have a choice. I'm going to install this in this computer, and we're going to put it in the car, and this is all live. We have not filmed it to this point. You can see the sticker still on here telling us to put the PROM in. And so it's pretty simple. It only goes one way. I don't think I can do both of these on camera and show it to you. the way that feels. Okay. One installed prom chip. We put the cover back on, plug our connectors back in, and remember that we now know for sure that we have another problem with this vehicle. Right? This was caused, and so now the rest of this video is going to be, let's find the real cause, which was, you know, I'm getting third-hand information here, but a stall whenever they step on the brake pedal was the symptom I got. So let's see what we got. Okay, we got the new computer installed. We have the air box put back on, intake air temp sensors plugged back in. A little warning on this system: once the battery is disconnected or a computer is replaced, these older 3.1, 2.8 GMs were very prone to start stall conditions until you did an idle relearn procedure or until you clean the throttle plate. So one of the two. We're not worried too much about that. I'm not going to panic if this car starts and stalls a few times. We have not started it yet, so we're not really sure what it's going to do. Concerned about the prom chip a little bit here. Our alternator is not a concern. That is bolted back up. Go ahead and try to start it. Let's see what happens. Nothing? Battery. Turn the headlights on. Oh, we must have left the key on. Battery charger. Let's make sure we have a good battery charger this time. Okay, while we're waiting for the battery charger here to charge this car up a little bit, just want to show you guys the turn the key on check engine light test. That'd be that bottom left corner. So watch it, guys. Turn the key on. There you go, cool. And I heard the pump prime, so all good signs here. We're going to hold off trying to start this for about 10 more minutes because I do not want to use the boost mode of the charger. I hate that thing. And we're going to give it about 10 more minutes to charge, and then we'll give it a shot. Again, this is a first attempt here. I really wanted to get this live, and I don't know if the battery's charged up enough yet or not. So go ahead and try it. Well, it's running. Sounds like crap. I hear some surging. All right, shut that off for a second. This surging that we have here, is this something that was there before? Is this something new? We don't know, and we're going to attack it. So we'll run the car, we'll get the scan tool back on it, we'll look at data parameters, we'll get it warmed up, and you know, see where this leads us. So go ahead and start it one more time. Let's take a listen to it for another minute before we do all that, and we'll go from there. Go ahead. Oh, shut it off for a second. I forgot to plug the map sensor back in.
That'll work.
That would do it. Did we is the TPS and pressure sensor plugged back in, guys? I think it is, right?
Yeah.
Okay. All right, start it back up. That's better. Funny when you have a critical sensor unplugged how a car runs, right? All right, so the surging, idle, we would have found that out real quick with a scan tool connected and a check engine light come on. What we need to do though is we need to warm this thing up, get it to the point where it stalls like they were talking about. Hit the brake pedal a couple times, that's what they were saying. When they hit the brakes, the car would stall. A little bit of surging there where you're hitting the brake, right? Could be an issue with the booster. You know, these are known for shorted injectors. Could be a dirty throttle plate, something very simple. At this point though, we fixed the computer issue. We'll see what else we come up with. You guys have seen me do this before. Grabbing the control wire for all 6 injectors on this design. And again, I'll throw a hyperlink in for the last video I did on these with shorted injectors. Just trying to trying to be really a detective here and trying to find the cause of the original complaint without test driving it right now. And I'm just doing a amperage check of the injectors. So let me get you a shot on the screen of what they look like. They look pretty good. Got a nice ramp. This looks nothing like that vehicle I showed that I'll throw the link in for, where we had some straight up lines here at the beginning. We have a nice curve right away. A maximum amperage of 4.7 amps at the peak. Each of these injectors draw about 0.7 a piece. So there's 6 of them. 7 times 6. 4.2, thank you. I didn't want to show people my math sucks on camera. 4.2 amps would be our peak, so we're a little bit high at 4.7, but I'm okay with that. This ramp looks good. The chances of this one being shorted injectors that were the original stalling complaint, surprisingly, is not the case. I mean, we definitely need to warm these up more and watch them and watch this ramp, but I don't think it's going to be shorted injectors. Something else that is a concern with these, I was talking to my guys about this. I should have probably filmed it. The IAC position on this, idle air control, a common issue is a dirty throttle plate. On this engine, very, very prone to that. Well, a lot of cars are, but this one's very prone to bad symptoms of coming to a stop and the car stalling from a dirty throttle plate. One of the things we look for is a higher than normal idle air control count. You know, what's our number right now? 35? 35 is not bad. We were just around 31, I think, a second ago. Pretty standard on a GM warmed up in park to have around 30 counts on an idle air control valve. So I don't think a dirty throttle plate is going to be the issue with this car. We're really left with nothing else other than to test drive this car and try to duplicate the complaint, the original complaint. You know, could it have been an issue with the old computer? Not as far as it blowing up, but you know, the board itself. These were known for it. The board having an issue, car warms up and stalls. We've all been there with these older systems. You know, is the car fixed now? We don't know. Test drive is in order, and then we'll hopefully find something, and if not, we'll just finalize this and say, hey, you know, cross our fingers, we'll give it back to the student, let him drive it for a few days, and then we'll go from there, see what happens. Some major twists and turns with this car, and we have yet another one here that I want to share with you guys. After a lengthy test drive, probably 8 to 10 miles, we had no issues whatsoever. The car ran great, no stalling, no nothing. So we talked to the owner of the car, and previously we had talked to another student that was working with him. This time we talked to the owner, who is one of our students. And he told me that he drove it to school, no problem, parked it, and when he went out to leave, his battery was dead. And so they were putting a jump pack on the car, and they got it started, and then every time they took the jump pack off, when he put it into reverse, put his foot on the brake, that's when the car stalled. So to me, that says dead battery, adding a load to the system. The battery's still weak, made the car shut off, whatever. Here's the point. It never was a stalling problem that was the original complaint. It was a dead battery. So how much does that change your direction? How important was it to get that first-hand information? I think it's a real good lesson to all of us. We're in the field, we take a repair order from a service manager and we take it at face value. We never call the customer. I've done it many, many times myself, and you know, another one gets you in trouble. So we know what happened so far, of course. You know, the battery blew up and all that in the process, but the battery was dead. So now it changes direction. Where are we going now? We want to look at charging system. We know our battery's new. We also want to look at parasitic drains. Is there a drain on this battery? What we noticed as we started looking at it, the battery was dead. Both times we looked at it, we didn't know if that was from someone else, the other group, messing around with it with the new battery in. You know, there was some of that going on, so we just really attributed it to that. Anyway, charging system check coming up, parasitic drain test coming up. That's where we're going, little shift in direction. The charging test that I'm going to show you guys, I'm just connected to battery negative with my black lead. My positive lead to my meter is going right to this BAT post, the stud on this power distribution box. I am using the Snap-on Varus for this measurement. Any simple voltmeter will work. Just going to the graphing meter, DC volts. We have our digital 12.6 and our line on the screen that you guys can look at. I'm just going to start the car, let you guys watch the voltage when I do it. Don't worry about that little start stall there. We actually have the battery disconnected. That is not an issue. That will go away once this vehicle relearns the idle. You see we got 14.2, so we know this alternator is charging. That's not good enough though. We want to load the system down, and to load the system without a load tester, we're just going to use the car to do it. I'm going to turn on the headlights, rear window defogger, blower on high, AC, watch the voltmeter. Okay, that is with all accessories on. And if you think about it, that's pretty much the maximum load that this thing is going to see. If you turn all the accessories on and your battery voltage still is maintained at a normal level, then there's nothing wrong with that alternator. Numbers we use, 13.5 to 14.7. But think about this, even if you drop to 13 volts at idle with all your accessories on, is the alternator still charging? Is the alternator still producing enough voltage to maintain the battery? And the answer is yes. So, you know, we don't like 13, it's low. But if you would see that, you raise your RPM. See what it does at a higher RPM. Remember, we're at idle on this car. So not much improvement on this one, but that's what you would do if you didn't like your battery voltage. All accessories on, there's nothing wrong with this alternator. It's not our issue. So charging system is good on this. Battery's brand new, we know that. Remember, our old battery blew up, so this battery's brand new. The new battery went dead too, by the way, and I did say that, but we weren't sure if that was just from people messing around with it, leaving the key on, who knows. Happens here a lot. So the last thing for us, why did this battery go dead in the first place? We need to do a parasitic drain test. And there's multiple ways to do this. I'm going to use the method that I'm most comfortable with, and we'll talk about some other alternative methods as we go. Next up, parasitic drain test. The method that I'm using for this parasitic drain test is I am going to disconnect the battery, which I've done. Here's my negative terminal. The battery, pretty tough to see on this little 2-inch screen here. The battery post is right here where my middle finger is. So I am off of the battery, and there's my terminal. What I'm going to do is I'm going to install my meter in series. And all that means is we're going to come from the battery, go through the meter, leave the meter, and then go into this terminal. So that would be in series. Now when we do that, we want to switch this, our leads up top on the Varus, we need to move over to this blue port that says 10 amp. So we take this off of here, we move this over to here. Now before we do that, we make sure our leads are disconnected from the vehicle. You do this wrong, you are going to blow the fuse in the back of the meter. Nice of Snap-on to provide a regular car fuse, not a specialty fuse like a lot of our meters. So I'm set up for the amperage scale. The connections are going to be one lead to the terminal, and I want to be on not really the bolt but the the metal part of the terminal here is what I'm trying to access, because the bolt will be loose and make and break contact. So I want to be on the terminal itself, and then on the battery post. It's a little bit difficult on these side terminal batteries. So what's nice about those big alligator clips. And let me set this back up and I'll get you a shot on the screen. Keep in mind when you do amperage testing like this, when you're in series, that what you have in your hands right now with the meter connected this way, with the yellow on the amperage port and the black on the COM port, basically you have a jumper wire in your hands. And I always tell my students that think of an ammeter as a jumper wire with a gauge on it. That'll keep you from connecting it up wrong. So would you take a jumper wire and connect it from battery positive to battery negative? The answer is no, not unless you want to start a fire. So think about that. It doesn't matter what I set this tool to down here. If I have my leads up here on an amperage setting, there's no resistance between my leads. Common mistake people make. So I need to set this up for amperage. There's a couple ways to do it. Just show you the easy way. We're going to amps internal. Hit yes. And I have a negative 1.14. No big deal, just have my leads reversed. This is a problem. I can either switch them on the battery or I'll just switch them at the top of the tool. It's just a little bit easier to do it that way. Show you guys that we have a amperage reading here. Now we have 3 amps, and that's actually good. Well, let's talk about that for a second. One of the bad things about doing it this way, when you're disconnecting the battery and you're connecting up like this, is when you first connect to it, you see how my amperage is even higher. You have to remember there are certain modules that when they are first woken up, when you first turn them on, they do certain things. And when you do parasitic drain testing, if you immediately start going after your testing methods and you don't wait for a period of time, you may cause misdiagnosis. I had a Ford Windstar once that I spent a long time on in a friend's driveway because I had around 800 milliamps of a draw, and you know the most that you want to have is around 50, typically 50 milliamps. And long story short, you know, pulling fuses and things like that, trying to locate this, it ended up being the BCM. And I read later, after getting so frustrated and going home and just telling him to put a battery in it because it needed one, I did some research on it and found that Ford, on that year, it takes 45 minutes or 50 minutes for that BCM to go to sleep after it's first turned on. So keep that in mind. Doing parasitic drain testing, there is a downtime you have to wait. And so for those of you that have different methods for doing this type of testing, those methods are valid, and what we're trying to do is avoid this making and breaking of circuits to try to find our drain. This is an older car. This will work fine, the procedure I'm going to show you. And again, as we go, I'll show you different methods that we can use, ones that maybe I'm not real comfortable with yet, but maybe we can all be comfortable with them together. Okay, so let's talk about this number we have. 1.13 amps. So to give you an idea of what we're allowed to have here, a typical number on most cars is really less than 30 milliamps. Now I'm saying most cars, I'm not talking about our newer systems. I've seen some newer systems that are higher. 50 milliamps is the number I've always used. That would be 0.05 of an amp, 50 milliamps. To give you perspective, this would be 1,120 milliamps. It's a huge number. 1.1 amps, way too high. Is this the cause of the problem on this car? And the answer is yes. This is what killed his battery. They brought the car into the shop. The battery was dead. Let me back up. They tried to jump start it, and it worked. But remember, with a battery stone dead, that alternator is basically full fielded trying to charge the battery back up. You turn any lights on, the car has the potential to stall from low battery voltage. we could use that as an explanation on the stall, or the fact that the battery was dead and this system's very prone to idle problems. You heard the start stall when I first started the car, so idle issues causing the stall. Had nothing to do with it, led us on the wrong path because we got the wrong symptoms. Dead battery was the main problem. They brought the car in, put it on the charger. You saw previously the charger was reverse polarity, battery blew up, then it came to us. We went through the process of diagnosing a bad computer. Very, very valuable lessons, I think. So great for us for learning, you know, not good for the owner of the vehicle. But you know, for any of you guys wondering, yes, we took care of this for him. So there was no cost out of his pocket for any of this. In any case, you know, we definitely were going around in circles with this car. Finally, we get the word from him that dead battery was the main thing, and we see why now, don't we? We have a 1 amp draw on this circuit that should not be there. Different methods, again, to track this down. I'm going to show you one that I've used for years. First thing, let's change this to a digital mode, which will allow me to do a zoomed out view for you guys. You guys will be able to see that amperage number on the screen, that 1.11 amps. And what I'm going to start doing is pulling fuses from the fuse box. Now there are 2 of them under the hood. There's one over here on this side, which is covered by a bar, and I'm hoping I don't have to go in here. And then there's another one over here on this side that I have the cover off already. And so I'm going to start in this location, and you guys can just watch the amperage number over there while I'm pulling these fuses. And normally I use needle nose pliers. I don't have any, so I'm improvising. I've got a pair of needle nose vice grips. I need to be very careful with these. I'm just pulling these fuses one at a time. So pull this fuse out. You look at your ammeter. We're still at 1 amp of current. And so I'll just keep going down the line. You guys can watch it. There's another one. No change. There's another one. So what we're looking for here, guys, is the fuse that I pull and that the amperage drops on. That would be the circuit that has the draw. Just going down the line. I've done this already, so I know there's no changes. And that's the last regular fuse in that box. No changes whatsoever. Now I don't know if any of those showed a momentary amperage rise. One of the things about doing this too is when you take a fuse out of a circuit, let's say that's for some type of control module, and what might actually happen when you plug it back in is you have a momentary amperage rise. You know, sometimes you can have an interior lighting system that is computer controlled, and you just woke that module up and turned the interior lights on. So you have to pay attention to what you're doing when you're doing this kind of testing. Further into this, we start pulling these maxi fuses. And there's a good example. That just amperage just went up to 2 point some amps when I pulled this fuse out. I don't worry about amperage rises. I just caused something to happen when I unplugged that fuse. I want to see an amperage drop. So don't let that mislead you as far as your direction and where you're going. Plug that fuse back in. That looks like to me interior light system's back on again. So we need to wait till that powers down. And you can see why people have adopted different testing methods. You know, imagine doing a system where you have 30 different control modules and, you know, 50 plus different fuses, and you're waking up and shutting down modules as you're pulling fuses. And there are other ways to do this. This is a very basic system. We can get away with it on this car. Now we're back down to our 1.1 amp. So we pull the next maxi fuse out. No change at all. So it's not that one. These ones are a little bit more difficult to get. No change on that one. Got 2 more maxi fuses to pull. Nothing on that. And we got one more. There's our drain, 0.01 of an amp. So we have 10 milliamps now on that. And this maxi fuse, this is a 30 amp maxi fuse. And what we need to do is we need to find out what is on this 30 amp maxi fuse. The distribution box diagram shows it as being this fuse right here. So nice that the other ones are marked. This one is not. What we need to do is we need to pull up a power distribution wiring diagram. That's what they're called in Mitchell. That's what I use. Mitchell On Demand. Power distribution diagram will tell me what is on this 30 amp circuit. So that's coming up next. This is page 1 of 6 of the power distribution diagram, and I found the fuse that was in our what they call RS electrical center. There is an LS electrical center and then an RS. I'm assuming maybe right side, I'm not sure. It is on the right side. This is our box. It is this 30 amp fuse right here. It was difficult to pick this out. Number one, since I've turned 40, I need glasses. I can't see very well. And looking through this 2-inch screen, I've complained about it before. Trying to film this for you guys is difficult. I'm squinting to see this. That's 30, that's 60, that's a 60. And this one's a 32. It says 3.1 and then 60 amp for a 3.4. And that was my clue there, because when I looked at the box, it actually says that. I wasn't sure on the diagram because I have two 30s here. This 3.8 is not us, so that's not even there. The rest of these are 60s. So I have two 30s. I wasn't sure which one on here it was, but it was a nice little note here. It says it right there, 30 amp and then 60 amp for the 3.4. And I see that right here, 3.4, 60 amp, 30 amp for the 3.1. So it was not that one. That's not the one that I pulled. The one that I pulled was this one that dropped the amperage, and that's this circuit right here. So we follow this a little bit further. Some of these older diagrams, they did them this way. Actually, this is pretty typical, I think, even on today's power distribution diagrams that Mitchell runs. This says 2 ignition switch, and that gives us an F. And then this says 2 elec fuse, probably electric, I'm not sure. E-L-E-C, elec fuse in the fuse block. So we have a maxi fuse protecting a smaller fuse, and then also splitting going to the ignition switch. So it's D and F. We find those components. Fortunately, they're on the same page, so it makes for easy camera work here. And what we can see is this is D from fuse K. That's where we just were, fuse K. That's this one right here, fuse K. That's our 30 amp. So that comes down to inside the car. This is the fuse box inside the car. There's a 15 amp elec fuse, E-L-E-C, right there inside. And then we also have pin, not really a pin, but it goes to F. And again, that's from fuse K, and it feeds this ignition switch. So we have a lot of different places we could have a problem. Now, if we think about this logically, the key's off. So in the off position, this circuit right here, it's really, I didn't mark this one because I know where we're going. This here to here, that's really the extent of that circuit. Those being off, we shouldn't have anything going anywhere. That doesn't rule out the fact that the ignition switch could be malfunctioning and we're powering something up. So we're kind of at a junction, and we're either going toward this or we're going toward this. And what I have found, the easiest thing to do is let's remove this fuse inside, see if our amp draw goes away. If it does, then we're on this leg of the circuit. If it does not, then we'll stay up here on this ignition switch. And with the ignition switch, you see if these close or if they're sticking, we have 3 more fuses that we can isolate to figure out which branch. But you can see it's going all over the place here. We got a big splice down here and a splice over here. And all right, so next step, we're pulling this fuse inside the car, and we're going to watch our amp meter when we do it. Now, one of the things about doing interior fuse boxes is you have to remember that when you open the door, you're going to cause an amperage rise. And so, I don't know if we can see our ammeter through the glass here. We're reading 1.09 amps. And if I open the door, you see that amperage just jumped up to 3.7, and we have some interior lights that are on. So close the door. Interior lights are off, but notice we're still at 3 amps on the meter, and my cluster is still lit. This has one of those Twilight Sentinel lighting systems on it. So we really got to wait till these guys shut off before we can start pulling fuses or yank that fuse for accuracy. So remember that, you open the door, you're doing parasitic drain testing, you have to really block that door or take that door switch and use something to close it. There you go, just shut off, and our amperage is back to 1 amp. So use something to close that switch so you can work inside. Now, I'm a little bit lucky on this one. My fuse box is here. I'm going through the window. Now, I got a glove box light that just turned on, so now we got to consider that too. So I'm at 1.4 amps now with the glove box light on. I can push that button in. Nice though, the fuse box is right here. And a little bit difficult for you guys to see maybe. But the fuse that I need to pull is this top one right here. It's the ELEC fuse. You see the designation 15 ELEC. So pulling that fuse, and I actually just heard a click inside the car when I pulled the fuse. And our amperage is down to 0.34. I know some of you are thinking, okay, we're good, right? We're not. 0.34 is 340 milliamps, not 34 milliamps. So this is where your decimal points come into play. 0.034 would be 34. So 0.34, that's 340. Next step, push this button in for the glove box, turn this light off, and let's get an amperage reading now. And that is 0.01 or 10 milliamps. Let go of the glove box switch. There's 340 milliamps. Push the button in, 0.01. So we know for sure now that our draw is on this ELEC fuse, this ELEC. I'm sorry, I don't know what the designation, electric. I don't know why they call it electric, but ELEC fuse, that is where our problem is. So before we go any further and try to track down the cause of this draw on this 15 amp fuse up here, what I wanted to show you guys is an alternative method for doing parasitic drain testing. And I have to be honest with you, I haven't used this method before to find a fault, but I think there's some real value in it. And that's because with this method, you do not need to disconnect fuses and plug them back in and make modules go to sleep and wake them back up. And I learned this from one of my friends at IATN, and it was a long time ago. I was reading a forum, and it talked about drain testing and somebody doing voltage drop tests on the fuse. And I've never done it, or I've never used it in the real world. I'm going to show you how it applies to this car, and you guys see what you think. I think it's worthy of adopting this method. And so the idea is, we know already that we have current flow across this fuse, right? This top fuse right here, we have 1 amp of current flow that's occurring in this circuit. The theory is voltage drops occur at every connection in a circuit. And so what we can actually do instead of pulling fuses and instead of disconnecting the battery is go to the fuse box and measure the voltage drop on the fuses. Only the circuit that has current flow will show you a voltage drop. And so I have my meter set on a low voltage scale, and I'm going to show it to you. And we'll go right to this fuse here. A voltage drop measurement is we're measuring or comparing the voltage between the two pins. Very difficult for me to do with one hand. I'm going to attempt to do it. And so measuring the tabs, those two tabs of that fuse, you can see that I'm reading 0.005. So basically 5 millivolts of a drop that's occurring across that fuse. And that's not much. I'm making and breaking contact there, and that's why it dropped to 0. That is not much, but there is a reading there. So let's measure one of the other fuses. And we'll measure this one right next to it. And to save time, just want you guys to know, I went through the entire fuse box and they all read exactly 0 volts. Only the one with current flow through it, which is this one, I read an amperage. Sorry, I read a voltage drop. That's what we're reading. A voltage drop across the pins of 5 millivolts. Try to get on that again. I'm having difficulty. There it is, our 5 millivolt drop across the fuse. So it's another way to identify which circuit has the draw, is to do this. Again, I haven't used it enough to know if it's valid in all circumstances. If you have maybe, let's say, a much lower amperage reading, maybe you only have 100 milliamps and you want to be under 50, is that going to be enough to cause a drop on the fuse? I don't know. There might be some variables with this test, but I think it's valid. There's one more I want to show you, which is this dome light circuit. Remember, the dome light's alive here, so we should have one more fuse in this box that shows me a reading. And I believe, again, I'm not showing you all of them just because it's hard to do this and film it. I believe it's this top one. Yeah, it's right there. So remember, the dome light was drawing around 340 milliamps. Sorry, not dome light. The glove box light was drawing around 340 milliamps, and that is the fuse for it right there. That circuit, I can't, I need a third hand if I can push this button. Watch it. There you go. 0 with the glove box light off, and 0.002, 2 millivolts of a drop on that fuse with the glove box light on. I think I've done this before, guys, and I think for the lower amperage circuits, it doesn't work. Like 100 millivolts is going to be pretty tough to see a drop on the fuse, but it is a valid test for higher amperage draws. I don't know. I still like my disconnect the battery version. Of course, we can use an inductive amp probe too, guys, and we can measure the amperage that way and not have to disconnect the battery. But using that method, you still have to pull fuses. To each his own, showing you multiple ways. This is our guy that is causing our current problem in our dead battery. We need to find out what's on that circuit. Back to the diagram. This is the fuse that we removed, where our amperage drops to 0 pretty much. That fuse comes down, feeds a bunch of components. These components: radio, passive restraint control module, lamp monitor, driver information center, low oil level module, HVAC control assembly, instrument cluster, Bose amplifier, left and right front door latch switches. Now, I crossed out some of these simply because this says Pontiac. Our car is a Buick Regal. This says Oldsmobile, this says Olds and Buick, and this says Chevrolet. So I crossed those ones out. And so that leaves us with radio, passive restraint, low oil level module, and left and right front door latch switches. Now, some further information here that I questioned the student previously to this filming is, what happened? What did you do before this battery went dead on you? And what he told me is the day before, he removed the factory radio and installed an aftermarket one. And so, man, you talk about some good information. Again, questioning the customer, one of the most important things that you can do, and that was it. So I'm saying that was it as far as key in giving us direction. We don't know yet if this is our problem, but it definitely gives us good direction. So I'll get you a shot inside of the car on what he did and why I don't think it's the radio. But really what we need to do, the process here, guys, is to take each of these components and to disconnect them. So a little bit difficult to do sometimes, and really gives you an idea of the time involved where we got to go through the car and find these modules and components, unplug them while we're monitoring our amperage on our battery. And when it goes away, we'll know exactly what system is involved and where the problem is. So that's the next step. I'll get you a visual on the radio install, and then we'll go from there. So you see the aftermarket radio. This had I think a cassette player down in here, and it had the radio controls up here. And what he did is he installed this, pulled the main control box out, and he mentioned cutting a wire unintentionally, and it was a wire that went in this direction. We were guessing that was probably dimmer control for the unit, and the wiring for these two went down underneath and under the glove box. We saw this stuff laying here earlier. We really didn't even think about it. They actually unplugged it when the battery blew up, just out of concern, so we didn't damage anything else. And this is the wiring that goes to the radio. This would be the install kit. And this did have an amplifier. So even though that said Bose amplifier on the diagram said for Chevy, you know, I don't know if it was a Bose amplifier or not, but it did have an amp. There is a antenna here, and there's wiring here that went into the amplifier. Now the original radio and wiring piece that came down to here is missing, and so this actually gets plugged into here. And by the way, there is no difference when I unplug this or plug it in. So one thing we know right away is it is not going to be that unit. That radio head unit is completely disconnected right now with this right here. So again, plugged into the car, unplugged. I still have my 1 amp draw. I don't like that that's when this started. So, you know, is it maybe something with the wire up in here that he mentioned? You know, we'll pull this box out and take a look. Something else that I think is worth noting for you guys is I want you to take a listen. And this isn't always foolproof. I'm gonna pull this fuse out and just listen. I'm going to touch the fuse on and off. Take a listen. Okay, so that clicking that you're hearing sounds like the door locks in the doors. And I wanted you to hear that, first of all, and then also warn you that when you make and break circuits, just because you hear activity does not mean that that's your problem. It could just be that I'm making a module go to sleep and then wake back up. And that's one of the normal things it might do, is to, you know, in this case, do something with the door locks. I don't know. Now the door latches were on the diagram, and I didn't pull the rest of that diagram to see what all was on there, but I wanted you guys to hear that. That gives us maybe a clue, but it might just be an effect, not a cause. So keep that in mind. You're pulling fuses out, putting them in, things will turn on and off. That doesn't mean that's your problem. That just might mean that that circuit is waking up and doing something. Now it could be, in our case, an issue that might give us direction, and we might be going toward the doors. I think after seeing the radio install, I don't think it's that, but hey, this problem didn't start till we touched the radio. So these parasitic drain tests can be difficult. Our next step, I think, is we'll remove this, take a look at the wire he mentioned cutting, and then we'll probably look at the wiring diagram again and see what is the next easiest system to disable or unplug. Last thing before I wrap up, I want you to notice that even with the ammeter powered down, with the Vantage Pro powered down, as long as my leads are still connected to this car, I will still have a drain on the system. Remember, when you use your ammeter mode, it is a jumper wire. So if you watch carefully, you'll probably see arcing here. Watch. I hear clicking. See if I can show you some arcing on this. You can actually hear can't show you the arc, but you can hear it. Listen. There was an arc. Just a little bit about ammeters, guys. Don't forget, it doesn't matter what you do down here. You have your leads hooked up in series up here. There is no resistance between your leads. You're holding in your hand a jumper wire with a gauge.